So photon interactions. And pair production. Okay, so there are four interactions that we will be studying. So the first one is the photon, so photoelectric effect. So basically, photon, right, it shines on the metal plates, right, and as it shines on it, this plate has the electron that comes out. Okay, and so photon generate electrons, and then that close the loop. And photons disappear in this case. So energy is absorbed by the plates. So all three cases, the first three cases, the photon disappear or absorb, right? Okay. The second case is the energy of the photon is not big enough. So this one here, the energy is big enough, it can actually generate the electron. But this one here, it's just the photon excited an electron, right? So electron, according to the Bose model, this electron, let's say for the hydrogen, right? So we have a proton in there, and we have an E minus. So this E minus can be excited to a higher state. So let's say that's n equal to 1, and this is n equal to 2. So if the photon comes in and strike the E minus, it can just have enough, good enough, the right amount of energy, or the exact amount of energy, so that it actually will kick this E minus to the higher state right there, and the E minus will then come over here. So it does not have enough energy to kick this electron out of the atom, but it does have enough to kick it to a higher energy state. Okay, and the photon also disappears, or the energy is absorbed. And number three, it's pair production, which we will study here, pair production. So pair production, it will require a really high energy photon. Typically, it's a gamma. So gamma, say for example, the lambda is equal to 10 to the negative 3 nanometer, or 10 to the negative 12 meter, right? So the wavelengths of this gamma, this is a gamma, right? Gamma particle, okay? Gamma photon, right? So, and you interacted with a material, right? And once you hit it, it actually, this energy, right? The photon is energy. This energy, according to Einstein, it actually was able to create mass, and this is electron, and this is a positron. Okay, so they are the same mass, and they will have the same kinetic energy too in this kind of production. So basically, a photon, gamma is still a photon, right? It's just one photon, and it can create two masses in this case if the energy is big enough. So this case, the photon also disappear, right? So photon disappear in there. Well, it's not disappear, it's converted into mass, right? But photon is disappeared. Right? Photon it's gone, right? The photon has created a mass, right? And so the last case here, this is so it's not, photon is not absorbed, right? But instead, It's something called Compton effect. So this one here is actually using conservation of energy and also conservation of momentum by Mr. Compton, right? So he derived this by using the Bose conservation law, and he was able to show that a photon, when it hits an electron or a nucleus, okay, this is a nucleus. So it can have a different kind of situation. Then this photon come in with a lambda, with a wavelength. So this is a photon, and it actually will deflect it. So that will become a lambda prime, which is larger than lambda. So your wavelengths increase, so your frequency reduce. So this is a scatter, right? So it collided and basically kind of like a classical particle, and it would actually kick out this electron. This electron will also move with the kinetic energy. So electron goes out this way and photons scatter that way. So this one comes in and the energy is not absorbed, right? So this photon is not absorbed. It's not absorbed. Instead, this photon is scattered. Okay? And the lambda increase, so means the energy, right? The energy of photon, this one here is less than the regional energy of this guy here, this energy of the incident photon. Okay. So that's the 4 type of photon interaction and pair production in particular is this one here that we describe here. And the formula that it will follow is such that the energy of this photon, the gamma, will be enough to create 2 masses. So in order to create 2 masses is 2m, and this m is the electron's mass. And the positron's mass is the same, E plus, is the same as E minus, and they both equal to 9.11 times 10 to the negative 31 kilogram. So positron, this is called positron. P-O-S-I-T-R-O-N, and in Chinese it's called 正电子. Okay. So this one is 2 MEC squared. Okay, you have to use the speed of the light when you are creating mass from the energy. So this one basically says that mass is one form of energy. Okay, so think of mass is just like energy. So this energy was able to use to create a mass, and you create 2 masses. And in addition to that, you have enough that you can actually give the kinetic energy to this too. And they both will have the same kinetic energy. And so that means they both will have the same velocity, right? So the velocity that created VE minus will be equal to the VE plus, and the amount you can calculate from this formula here. Okay. All right, so that's where we're going to stop. And thanks for watching. Until